Hello, welcome back to Learning with Ms. H. Today we are in Earth Science and we're going to be talking about our Introductory Caves lesson. We're going to spend a few lessons on caves themselves, how they're formed, what kind of formations they have inside, all kinds of different information about caves. So for today, we're going to be taking notes. So go ahead and get ready to pause the video. You do have a bell work assignment. Your starter today is to explain what you think a cave is and how you think it forms. So access your prior knowledge to determine what you think a cave is, how it forms. Jot that down and then come back and rejoin us for the notes, and we will get started with the lesson. All right, hopefully you've got your bell work done. If you scroll down to the bottom, I'm going to go ahead and go over the assignment with you here very quickly before we get started on the lesson itself. So go to the assignment section, click on that assignment, and you'll see that this is one of our not a quizzes. It's got about 20 questions here for you to go through, and there's all different types. There's true, false, multiple choice, multiple select. Look at the image and answer the questions. A good mix of questions here for you to answer. Remember, this is not a quiz, so you can take this as many times as you need to until you get a grade that you are happy with. So if you are one of my students who likes to do these notes on your own, you can go ahead and stop the video here, do your bell work if you haven't already, go through the notes, and then go through your homework assignment. If you are one of the students who likes to go through the notes with me on the video, go ahead and keep watching and we're going to get into it. So today we're going to do the first of our lessons on caves. We're going to look at how caves form and the types of caves. We're going to look at the actual features inside of a cave in an upcoming lesson. So the first thing you need to know is what a cave is. And a cave is basically, in layman's terms, a hole in the ground. If it's a hole in the ground, it qualifies. It can be natural or man-made. But it is some type of hole in the ground. It can be made of different types of rocks, but they are all going to be soft rocks that are easy to dissolve with a weak acid. Most of the ones that are in our area are made out of limestone. They can also be made out of marble, gypsum, dolomite, several types of materials that are very soft. You can have caves made out of other types of materials. If you have sea caves, those are generally going to be harder rocks, but they're being pounded away at by the ocean waves. You can have grottos, rock shelters, lava tubes. We're going to talk about several different types of caves today. You might have heard the term cavern. A cavern and a cave are completely different. They're both under the ground. However, caves have no light source whatsoever, whereas caverns are going to have some type of natural light in them. There's going to be some source of natural light coming in. So in our image over here, you have natural light coming in from the left on this top cave. So natural light here coming in, this would be a cavern. However, this one down here on the right-hand side has no natural light. That would be a cave. Again, you have natural light coming in from above here, so this is a cavern. Possibly all the way down into here if there's natural light coming in all the way down here as well, cavern. And then this one over here that has no light, that's a cave. You can see some of the features in this image on the right-hand side as well. You're looking at a limestone cave. You've got stalagmites, columns, stalactites. We're going to talk about each of those features in a future lesson. As always, when you're going through these notes, I'm going to go through them a little bit quicker than you may need me to. So feel free to pause the video on a slide if you need to take some more time to write some things down. That's totally fine. Pause the video, finish writing, and then restart the video when you are ready. If I left a long enough time for you to write, these videos would be, an hour long, and I don't want that. But take your time, go through it, at your own pace. So this animation shows the creation of caves using the method of dissolving the rock with carbonic acid. Carbonic acid is a very weak acid that dissolves the minerals from the rock. We talk about it and say that it eats away at the rock, but it's dissolving the minerals out of the rock. It creates cracks and crevices that grow over time into these giant holes or rooms even, these hollow spaces underground. Rainwater combines with carbon dioxide in the air, becomes groundwater, seeps through the crust into the underground regions, dissolves away the minerals, which breaks down the rocks, and now we have caves and caverns. It's a mild acid. It's not really going to be harmful in small amounts to humans, but it does cause these caves to happen. Again, some of the soft stones that this can happen in: limestone, chalk, dolomite, marble, salt, and gypsum. The more weak acid flows into the rock, the more they dissolve. The larger the open space, the more water can get in, the more it dissolves, and you have a cycle happening. And that's how the caves grow. So this is a short animation showing how Mammoth Cave in Kentucky was formed. It's actually the longest cave that we were aware of when I created this slideshow presentation. So pause the video, watch this animation, and then rejoin us. Alright, so we are going to talk about Mammoth Cave in a little bit here when we talk about the limestone caves. We've got kind of a collage of caves here. We've got several different types of caves: sea caves, limestone caves, multiple different types of caves. We're going to go through all of these. The first one is going to be a limestone cave. This is what we usually think of when we think of a cave here in the Midwest. It's the most common cave we have around here. They are the longest and deepest caves found all over the world. And again, the one in Mammoth Cave in Kentucky, that cave is about 350 miles of mapped passages and rooms. For those that are not in the States, that is 560 kilometers long. Sea caves are the next type, and they are just what they sound like: caves by the sea. This is going to be the rock cliffs where the ocean waves are crashing up against the face of the cliff, causing damage to it, weathering away or eroding away bits of the rock until it makes its way, eating away at the rock, deep into the rock, and you form these overhangs and eventually possibly even deeper caves. The top image here is the entrance to a sea cave. The bottom two images are of grottos. Now, not all grottos have this blue light to them. Some of them are green. Some of them are actually made by man. So they're not natural grottos, they're human-made grottos. These two images here are natural grottos. They are sea caves where there is a light source coming in, and they're shallow enough that the light source reflects off the bottom of the cave and causes this bluish glow. On the left, you have the Grotto of Capri in Italy, which is an image that actually came from one of the royalty-free websites. And then the right is the Blue Grotto in Croatia, and one of our collaborators for this project actually went there and took that picture. Basically, a grotto is a very small cave that's kind of cozy and calm and mellow and relaxing. The natural grottos are just like these two. The man-made grottos can have all kinds of different things in them. They can be decorated, they cannot be decorated, they can be lit or not. Um, we do all kinds of weird things to the caves to make them more comfortable and seem like a nice, relaxing place to be. Our next type of cave is going to be a lava tube. Lava tubes form when magma erupts in volcanic activity. When it reaches the surface, we call it lava. The lava flows down away from the volcano. As it cools off, it forms igneous rock. And if you have the surface cooling while the inside is still flowing, you end up with this hollow tube. So this is where the lava would have been flowing as the outside rings of rock, these outside surfaces of rock were cooling all around, and the hot lava was still flowing through. And you end up with these hollow tubes going away from the volcano. So lava tubes are a little bit different from all other types of caves. Most caves, the rocks form, and then later on, they're dissolved away or weathered away to form the caves. When you have something like a lava tube, that is considered a primary cave because the cave forms at the same time as the rock around it. So the rock that the cave is in is formed with these hollow openings in it already. So it all happens at the same time instead of rock first, openings dissolving away later. Other examples of primary caves would be rift caves, lava mold caves, and inflationary caves. One of the more famous lava tubes is Kazumara Cave in Hawaii. It is the longest and deepest lava tube that we are aware of when this presentation was made. It is just under 41 miles long and just over 3,600 feet deep. Our next type is going to be glacier caves. Now, glacier caves are made of ice, but they are not the same thing as an ice cave. Ice caves are made from regular rock, and the water gets in there, and the conditions of the cave inside that rock make it so that the water freezes inside there and is perpetual ice. It never thaws out. Once it goes in, it freezes, you're done. Glacier caves are different. Glacier caves are actually formed from the ice, not from the rock. So a glacier cave is, guess where? Inside of a glacier. A glacier is a large sheet of ice. As the water flows underneath it or through it, the glacier thaws out. It forms these little rivers of water underneath it. Those rivers of water are going to carve out the ice and flow out of the glacier somewhere. So as those rivers flow, they carve through the ice and you get these caves. These are not always going to be the same size, shape, location. Some of them may eventually freeze over. You may have new ones form, and they may actually change in structure. So you have new chambers that may form by being hollowed out. So they're always changing. Ice caves, you have regular caves that form, and then again, water gets in there and freezes. The one you're looking at here on the right is the Bandera Ice Cave out in New Mexico. And while we were there, there's actually a volcano there as well. And what happened to form this cave is one of the lava tubes from the volcano actually collapsed and created this cavern, called a cavern because it has a natural light source, because one side of it is open to the air, to the sunlight. And then the temperature in here, because of the insulation from the lava, it remains at a maximum of 31 degrees inside this cavern. So we're standing on basically a deck outside of the cave. And if you go up about 10 feet, it is normal outdoor temperatures. But on the deck down here at the bottom, right by the opening of this cavern, It is getting fairly close to 31 degrees. If we were to actually go into the cavern, it would not be above 31 degrees no matter what temperature it was outside. So you have a pool of ice here. You have a curtain of ice over here, and then you have some, these would, if they were not ice, they would be considered stalactites because they're coming down from the ceiling, but this is water that is dripped down from the roof of the cave and just frozen in these shapes. Our next one, sandstone caves up here on top. These form from water and wind eroding away the sandstone rock. The ones that are in the picture here are the Mormon rocks in Cajun Pass, California. These are always found on the interior of a landmass. The bottom here is a mud cave, and it is kind of what it sounds like. It is hard mud, solidified mud. This is the kind you would have to take a pickaxe to. You wouldn't be able to dig in it. But you have water that flows through these silt deposits. The silt causes this mud to solidify. The water flows through, dissolves it away, removes some of it, and you get these caves. This one in particular is from Anza Borrego Desert State Park near San Diego County, California. Some unusual types of caves that we wouldn't normally consider a cave: sinkholes and talus. A sinkhole is basically what happens when the roof of a cave collapses. So you have a cave that's formed underground. It gets larger and larger, and eventually the roof of it is not supported enough, so it collapses in on itself. When it does that, everything above it falls as well, and basically fills in the opening that was the cave. Whatever's on top of it falls with it. This one in particular on the left happened in a neighborhood. It's a really large sinkhole. It's a very bad day for these people down here. A lot of times this can happen naturally if a cave gets large enough from just natural causes, natural dissolving of the minerals making it larger, or even maybe an earthquake, something like that can cause it. So it can happen from natural causes, but a lot of times this is going to be the result of human activity. Not necessarily the creation of the cave, but the reason for the collapse. All of these houses built on top of it. These guys built on top of this cave. They didn't know it was a cave, obviously, but the added weight of all of the structures that humans put there made it so that the roof of that cave could no longer support the material on top of it. It would possibly have stayed there forever if it was just the thin layer of actual crust on top, the ground. But when we add weight to it, that puts stress on it, and that will cause it to collapse. This happens in karst landscapes. Karst landscapes are those landscapes with the really soft rock that are prone to caves that we talked about previously. Talus. A talus is going to be our last type of cave that we're going to talk about. It's also known as a boulder cave. It's basically a opening in the ground. It has a bunch of boulders there that block it off. All of these gaps in the boulder pile are what we're looking at here. This is a talus with a bunch of boulders and all these gaps behind it here. This is our last slide for the day, and we're going to take a quick look at the features inside of a cave. We're going to take a closer look at this again when we talk about Jacob's Cave, and you'll go into detail on these. For right now, you need to know that these are called speleothems. They are features created by the deposition of minerals. So as the rainwater, or carbonic acid, flows through the ground, it reaches these spots that are larger openings like this, and it drips down from the roof. It's no longer crossing any rock, so it's not dissolving any more minerals. So what's going to happen is that mineral is going to precipitate out. It's going to get deposited. It can get deposited on other minerals that are hanging from the ceiling already. forming these stalactites because they hang tight to the ceiling. If it drips off of the stalactite and hits the ground of the cave, it will start building up from there, and we call those stalagmites because they just might reach the top. If you get to a point where the two features, the stalactite and the stalagmite, are going to meet in the middle here, like this one has, you get what's called a pillar or a column. So the water seeps through the ground, dissolves away the minerals as it goes, becomes carbonic acid because of the acid rain that we've had, or the carbon dioxide mixing with the groundwater, dissolving those minerals. Carbonic acid does its work. It gets into the cave. It deposits those minerals, forming all of these features. That's the short version. We're going to look at Jacob's Cave coming up and talk about some of these features as we see them in an actual cave. When you are done with this, go ahead and work on your homework, and when you're satisfied with your grade on that, you are done for the day. We'll see you next time.